We've done an introduction to graphing rational functions, especially by looking at the asymptotes, both vertical asymptotes and horizontal asymptotes. But what if, instead of a horizontal asymptote, the end behavior is affected by a different type of asymptote? So we're going to look at a bonus problem here to kind of look at what happens with higher degrees. So with this one, we're going to look at this function here, x squared plus 2x minus 5 divided by the quantity x minus 1. To first find the asymptotes, we do know that the vertical asymptote is based on the denominator. So the vertical asymptote will be this denominator set equal to 0, so I get x equal to 1. So I'm going to draw that vertical asymptote in. So that denominator still holds to provide values that are not allowed in the domain, but then we want to divide the denominator into the numerator using polynomial long division, or you could use synthetic division. I'm going to demonstrate with polynomial long division. And this will give us a different type of asymptote that the end behavior will follow rather than a horizontal asymptote. So x times x gives me the x squared. Multiply x times both of these, and then subtract. No more x's. 2x minus a negative 1x gives me 3x, because that will be a plus 1x there. Bring down the negative 5. X times what gives me 3x? That's a plus 3. 3 times x is 3x, and then minus 3. We're going to subtract again, and again we have 3x minus 3x is gone, but minus a negative will be a plus, so negative 5 plus 3 is negative 2. So this expression here will equal, this is the same thing as x plus 3 plus the remainder, negative 2, over the divisor, x minus 1. This is the same value as this fraction here, but it's in a different form. And what it shows us is that this x plus 3 pops out now instead of a constant like we've done on the other horizontal asymptote problems we've done. And this fraction will go to 0 because there's a constant over either a very large increasing x value or going to negative infinity. This fraction will go to 0. So this x plus 3 is what the graph will look like. That x plus 3, y equals x plus 3 is an asymptote. It's called either a slant asymptote, because it's in the form of a line, or it's called an oblique asymptote. Those are the phrases we use for these. And it looks like this. I start the graph at 3 here. I go up 1 over 1 and draw a dotted line here. So just for these. And then I draw all the way this direction. And what this tells us is, as it goes to infinity in both directions, it's going to follow this line instead of a horizontal asymptote. So when we graph this, if you were to put this on your graphing calculator, what you would see is that the graph would be very close to the asymptote here during this one as it goes up here in value, increases, but then when it gets to this vertical asymptote, it will follow it instead, and then down here it follows the vertical asymptote here from the negative, and then it follows the slant asymptote after we get past getting close to the intersection point of the asymptotes. So if you were to zoom out on this, what you would see is that the end behavior looks a lot like this line, because this graph is going to get very close to the slant asymptote, and it will get very close to the line up there. In the middle here, it's going to follow the vertical asymptote and not look like the slanted line, but the end behavior as x goes to negative infinity, the y is going to go, it's going down, following this line down to negative infinity. So the y goes to negative infinity, following this line. And as x goes to infinity, following it this direction, notice it's going off to infinity, following the line to infinity. So these slant asymptotes are when the degree in the numerator is 1 degree larger than the denominator. Later you will look at in future classes, courses, you'll look at when the degree is too larger, then you'll have an asymptote that looks like a parabola. It will change according to the degree that you have that's higher in the numerator versus the denominator. So when you have a problem like this where the degree of the numerator is larger than the degree of the denominator, so this is the situation we're dealing with. The degree of the numerator is greater than the degree of the denominator. What we have for this problem is that you're going to get an asymptote other than a horizontal asymptote. If it's 1 degree larger, it will be a slant asymptote or an oblique asymptote, a line that goes off and slants. If it's a couple degrees or 3 degrees larger, you'll see a different polynomial asymptote that will help you determine what the end behavior of the graph is.